Today what we're going to do, we're going to go through AI, ANI, AGI, and ASI, and we're going to break them down, define them, and let you know why we're probably not at AGI yet. My name's Omar, I'm a cybersecurity expert with a heavy interest in AI, and I've been pivoting towards AI security specifically for a while. So here's the plan. Let's go ahead and define these, as I've just mentioned, the things that we're going to talk about. A practical test then for AGI-ness, let's say, and I call that the CGA triangle, which is a very good measure for actual true intelligence, especially for AI. That's capability, generality, and autonomy. So artificial intelligence, as we mentioned in the previous video, it's the umbrella. Machine-based systems that infer from inputs to output. That output can simply be predictions, content, recommendations, or even decisions. In plain English, AI is essentially software that learns patterns from the data to do something useful. Now, let's move on to ANI, Artificial Narrow Intelligence. These are our specialists. They're great at a slice of reality like a chess engine or a medical image reader or even a customer support bot for one product. They're super capable within the scope that they are designed for. However, for anything else, you could completely forget about it. A lot of people may be thinking right now of agentic AI as one, is for coding and one is for assistance. The thing is that you're maybe 20% correct here. And why is that? It's that agentic AI is actually a lot more capable than artificial narrow intelligence. It's simply because it just builds upon the abilities of artificial narrow intelligence, and it takes that and wraps it in a system which makes it accessible for users to actually interact with, like ChatGPT, via the prompting. So ANI and agentic AI, I just wanted to mention that these are two separate things. However, they are related in principle. Now, onto AGI, Artificial General Intelligence. These are generalists at human level. A very practical definition that you may come across, especially if you're reading from industry standards, is that AGI is highly autonomous systems that outperform humans at economically most valuable work. That is the concrete definition, the industry grade definition. It's not necessarily smart at trivia, but it can reliably do most of the jobs that other people would do. And that's when you're talking about human-like level intuition and intelligence. And that's where it comes in that obviously, if you think of it like this, when we're saying there is no standard for human intelligence, for example, you may be smarter than me, it may be vice versa. Other people have different varying levels of intelligence. But essentially what we're saying here is that it can do this without the need for babysitting. And this also ties into the three measures that we have. And when I say the three measures, I'm referencing the triangle: creativity, generality, autonomy. Now, this is the interesting one. ASI, artificial superintelligence. This is like a hypothetical of post AGI achievement. And the reason we say this is because we're not at AGI yet, but ASI is essentially beyond human intellect across virtually all domains. And a good way to look at it is the following. If AGI is the pure human, meaning, let's just say the average standard level, right? ASI is an intellect level that makes our best geniuses simply look like just calculators, something that you use here and there. You can definitely get a good answer from them as long as you put in what you're looking for correctly, but at the end of the day, it's just something that we use. Now, the practical test that I was talking about earlier is this AGI? And what do we mean by this? That is when we reference our triage, which is creativity, generality, and autonomy. So let's make AGI testable with this triage that we have. So capability, how good is it at tasks? I'm talking about the accuracy, the reliability, and most importantly, the truthfulness. So can it admit when it has uncertainty rather than bluffing and what we know commonly nowadays as the hallucinations? The next measurement, generality. How broad is its competence? Can it, for example, transfer its skills from one domain to another without needing much hand-holding? And finally, autonomy. The point here is, can it plan, act, and self-correct over the long term, especially with changing goals and constraints? And that's where we're talking about removing the human from the loop, which is usually that stigma of fear that if AGI is achieved, it can take everyone's job. So AGI amongst this triage lives in the high corner of every single part of that triangle. So if that's the reference you have for AGI, I'm sure you can only imagine where ASI would sit. Today's best systems are very capable and increasingly reliable. However, autonomy, so removing the human from the factor, and reliability are the sticking points that are really crucial for us to be able to say we have reached AGI, and this is the thing that's dragging us back at the moment. So the triangle, we have capability is increasing, generality is increasing, Autonomy is stagnated, let's say. So where are we right now in 2025? So let's discuss the positives at the moment. The frontier models are known to be acing a lot of the benchmarks that they have been assessed against. They translate, summarize, write very tough code, and also pass very tough exams. And here comes the reality check. The benchmarks that we're talking about, that we measure these LLMs against, are not the real world. So this is where we're saying that in a controlled environment, these AIs are passing with flying colors. However, when we go to real world scenarios, they are having a lot of issues. And the issues that the real world is introducing are things like ambiguous goals, messy data, disagreements amongst stakeholders, and multi-week projects. This is where the cracks begin to show when LLMs is supposed to amplify on the autonomy part of the triangle. It's supposed to be able to do this with little human intervention. That's what we're saying for AGI. So there's three recurring pain points when we say we're not at AGI yet. Hallucinations, fluent and confident errors where the model should actually come back to us and say that it does not know. However, obviously, when it comes to hallucinations, this is part of the characteristic of an LLM, as this is a large language model and it's just designed at its core programming to actually go ahead and finish what it's meant to say, regardless of if it knows or not. It's not a fact-checking model, it's a language model. It's supposed to sound coherent and fluent. The other point is brittle transfer. So it's strong within distribution, but very shaky when it goes out of that distribution, and it requires tools and various grounding. And the third point, long-term, long horizon planning. So that's keeping plans coherent over many steps with memory and recovery from mistakes. So let's discuss actually why we are not at AGI yet. The first point is reliability is part of capability. It is not enough to be right often. You must be right all the time. And when you do not know, the AI should go out of its way and escalate and seek help to be certain. So the issue is that today's systems are still bluffing to us. Again, this is the hallucinations. They don't know how to quantify uncertainty like a lot of the mature engineering systems that we currently have. So that's where a lot of these most economically valuable work, as per the AGI definition, asks yourself what the trade-off is. Is it really worth us trying to do that? The second point, generality without brittleness. AGI must handle novel tasks gracefully. New tools, new domains, shifting constraints. It's true that LLMs are broad. Yes, that is true. But true generality means robust, casual understanding, not just correlations. Without tools, sensors, or retrieval, they can still confuse surface patterns with real structure. Now, the third point is autonomy over time. AGI must be able to plan, act, check, revise across days or even weeks, maintaining goals, managing resources, also recovering from a lot of surprises that are very common in our real-life projects. One of the issues now is that current AI agents need heavy scaffolding, including planners, memory stores, search tools, external verifiers, and most importantly, human oversight. Because obviously, as you know, the whole point of AGI is for us to be able to then remove the human out of that loop. As you guys know, one of the debatable points of AGI is that it should be able to have autonomy. It should be able to do things without human oversight and not have a human in the loop. So our current AI, is it useful? Yes, absolutely. But are they autonomous CEOs of complex projects? Absolutely not. I will also play a bit of devil advocate's role very briefly on some of the points which some people may say that we're at least at proto-AGI stage. So the top models be average humans on a lot of tasks and including writing code. So one of the main reasons is that our top models are able to beat average humans on knowledge tasks and are able to write production code. But this is the key thing here. It's a fair point on capability at least, but if it's still hallucinating under stress and struggles with casual reasoning and needs a human project manager for a long horizon piece of work, we're not in the AGI corner of the triangle. We're in the super copilot zone, as still the human is part of that loop. And the whole point of AGI is that it has to be, again, right every single time. And it's better than the average human, because also the average human, or many humans, varying intellect, do make mistakes under stress, and this is what we're trying to also solve and beat. So the super copilot that we may have at the moment is simply not the same as AGI, because we are not meeting all of the three requirements of that triangle. Now, what is it that likely will get us closer to AGI? So the tool usage by default. What do I mean by this? Search, retrieval, code execution, structured memory, let models check claims against sources and even simulate actions before they're actually allowed to even act. The next point, grounding and provenance. So for example, you want to tie the statements to evidence. You also want to showcase where does the fact actually come from that we are declaring. And obviously by design, we want to reduce hallucinations. Obviously now LLMs, again, it's a characteristic of them to hallucinate, since again, as I've mentioned already, the core programming of an LLM is for it to complete the sentence that it's saying regardless whether it knows or not. This is why I explicitly say in some of my other videos that what you need to do is actually prompt it in a certain way or give it instructions that if it's definitely unsure to tell you that it doesn't know. However, what we're saying here, we want it by design to come out of itself and reduce the hallucinations. So if it definitely is unsure and it cannot find anything that is verifiable, it will say, I do not know. And the final point of how we can get to AGI, which is very important, is the human in the loop when there are high stakes. So think of it like Autonomy, but with some guardrails. That's the same way as, ChatGPT is a system that takes LLM, the engine, and it adds its own guardrails, so you can't prompt it with anything, for example, abusive. So we do not want a set and forget, that we plug it and we play it and we let it do as it likes. We do want guardrails in place, especially for those high stakes scenarios. You must have mitigation strategy. Now, the next thing I actually want to touch upon is how to spot empty AGI claims. And this is probably very important for you as an investor, if you are an investor or someone who's looking into AI and there's something, monetary wise it's involved. There are 3 red flags we should look out for. Cherry pick demos. So you want them to show you distribution wide performance, not just one gold take. Short horizon tasks dressed up as autonomy. So as you know, real autonomy actually survives calendar time, different changes within objectives and goals, and also constraints over a very long period of time. What you would want to look for is that they are dressing up a short-term task goal achieved that can be achieved nowadays by any LLM, and they say this is autonomy, that it's able to do this without a human in the loop over a long period of time. And the final red flag, no audits. So if there's no uncertainty reporting, no error analysis, no provence, it's just going to simply be a marketing scam, not science. So there you go. We've just gone over quite a few things. We went over AI, AGI, ASI, ANI. How can we get to AGI while we're not at there yet? And so just let me know what you guys think in the comments. Do you agree or disagree? And what would you want to see next? Thank you so much for watching the video, and I hope you've enjoyed.